There's a feeling that the thing that kind of grabs us all in to begin with is that physics is about, in some ways, the fundamentals of the universe, right? There's some view that what we really want to be able to do is I want to be able to go to the whiteboard and write one or two equations up on the whiteboard, and then, okay, it might take me a few months to go through it all, but from those one or two equations, eventually it's going to come out everything that we know, that you can derive the whole universe. And it's true that physics has been about traditionally attacking those fundamental problems. But physics is actually a rather acquisitive science. What physics does, if you look at the way physics works, is it will pick a subject, it will work on it for a long while, and then when it feels it's got all the interesting stuff it wants, almost spit it out and move on to something else. So you have whole areas of science which in a way have become unfashionable for physicists. And that then is what it really tells you, okay, that physics is about. That physics is not about those fundamentals. It's about a toolkit of things that you can use to attack a problem. So for example, the physicists are at the moment very important in studying nanostructures. Okay? Nanostructures is about fundamentally how you join atoms together to make bigger structures. And you might think that was going to be something about chemistry. But of course, if you're a physicist, you look at a long rod of material where you've glued atoms together and it flexes and it stretches, it compresses, you can bend it in other ways. Those are all properties that that we have analysis tools for because we're used to applying them in other bigger situations. And so where physicists can find a way, okay, find that their tools are useful, they will apply them. So if, for example, I was advising someone now about what to do with physics, okay, where to go if they were going into research, one of the big areas which is opening up at the moment is biomedical physics. Not physics about, although this is a big field in itself, not physics about the machinery that you use in medicine, okay, which is another area that physicists moved into and have made large contributions to, but actually understanding pieces of biology as a piece of physics. So if you think of a blood cell, for example, at the end of your fingers, the veins, the capillaries that your blood is in, get so small, blood cells are too big to go through them. The only way that they can go through them is because they deform. Again, it's about deforming things, stretching things, okay? And again, it's a natural place for physicists to be. So that, I think, is now what should really attract people in, that as physicists, we have contributions we can make to fields that you might not think of traditionally as physics, but which are going to become very heavily populated by physics, I suspect, in the next few years.